In this video, we're going to talk about oxidation reduction reactions, okay? And we need to know the difference between what's being oxidized, what's being reduced, as well as the reducing agents and the oxidizing agents, and what are the differences. So we define oxidation as a loss of electrons, okay? Now, there's something here to remember, very important. Any element in its natural state, solid, liquid, or gas, the charge or the oxidation state is zero. So that's very important. Okay, so you can see that if we take sodium metal, its oxidation state is zero. Okay, we're gonna gain Na plus an electron. Okay, so a question to ask yourself whenever it's being oxidized is the atom or compound becoming more positive? Okay, and that's what we define as oxidation. When we talk about reduction, we talk about the gain of electrons. So if I take chlorine gas and I add 2 electrons, I'll get 2 Cl minus. And notice that my atom is becoming more negative. So the question to ask yourself is the atom becoming more negative? And that's what constitutes reduction. And so there's a funny little thing that we say, and this might be able to will help you remember. It says Leo the lion gurs, and essentially what we mean by loss of electrons, oxidation, gain of electrons, reduction. Okay, so very important. So let's take a look at an example. So we have sodium metal plus chlorine gas, and we get sodium chloride. So my question here is which one is being oxidized and which one is being reduced? Okay. Well, if I look at the reactant, well, what's the charge on sodium? Charge on sodium is zero because it's a solid. It's in its natural state. And so the charge went from zero to now look, we have sodium chloride. Well, if we break sodium chloride up into its substituents, we actually will get Na plus and Cl minus. Okay, so this was from Na0 to actually Na plus. Okay, and we could definitely see that the atom is becoming more positive, and so this is what we call, this is actually being oxidized. Okay, now with Cl2, it's a gas and it's in its natural state again. So again, that went from 0 to actually Cl minus. Okay, so that's becoming more negative, so we call that's actually being reduced. Okay, now here's the trick with finding your oxidizing agent and reducing agent. Whatever is being oxidized is actually your reducing agent. So this is your reducing agent. Whatever is being reduced is your oxidizing agent. So this is a great way to remember which one are your agents. Find out which one is being oxidized first and know it's the opposite. Which one is being reduced is the opposite agent, okay? Let's take a look at this one. Well, notice that we have hydrogen. It's a gas, so its oxidation state is zero. And if we break up HCl into its parts, we get H plus and HCl minus. So the charge went from 0 to H plus, so we know this is being oxidized. And again, chlorine, because it's a gas, in its natural state, it has oxidation state of 0, Cl2, and that just went to Cl minus. This is being reduced. This is being reduced. Okay, and so we know anything that's being reduced is our oxidizing agent. Anything that's being oxidized is a reducing agent. So that's a great way of remembering these things. Okay, and by definition, let's say oxidizing agent oxidizes something else itself becomes reduced. Okay, and reducing agent reduces something else itself, it becomes oxidized. Okay, so a great test question might be something like this, where an equation is given to you like this, and they might ask you, well, what is the reducing agent? Well, the first thing I usually do is find out what's being oxidized and what's being reduced. Okay, so if I look at potassium, well, it's a solid, and so we know the oxidation state is 0. So that went from K0 to, well, potassium hydroxide. If we break that up into substituents, we get K plus and OH minus. Okay, so you see that this went from K0 to K plus, and we define this as being oxidized. So we know potassium actually was being oxidized. Well, if it's being oxidized, then we know it has to be the reducing agent. So in fact, potassium here is actually your reducing agent. Okay, so that is the process, and this is how I like to do it I mean, it minimizes confusion.